All right, this video is for the review of exponential functions notes and practice. There'll be two videos for the notes. This is video 1. We'll just do examples 1, 2, and 3 on here. So the first couple examples. So we're going to use the word bank to fill in the blanks here. So it says we've dealt with linear functions of the form. So you have to be able to identify from the word bank which equation is the linear function. That would be y equals mx plus b. So we'll throw that guy on the line right here. So we've been working this year with lines in the slope-intercept form, y equals mx plus b. Now we're going to switch to exponential functions. And hopefully you remember from Algebra 1 that exponential functions are of the form y equals a times the quantity b to the x. Okay? Now the a and b, just like in y equals mx plus b, the a and the b have a meaning. The a is what we call the starting value. That starting value is also known as the Y-intercept, and B is called the growth rate. Right? And we're going to see two different kinds of exponential functions. We're either going to have exponential increase or exponential growth. And exponential increase happens if that B, that growth rate, is greater than 1. And the exponential decrease or exponential decay is when the B is less than 1. But I also want to say that the B, we're going to restrict it here to positive values of B. So also greater than 0. Right? So a decimal between 0 and 1. Now let's just review some basics of exponential functions here. So I want you to identify the y-intercept and whether it's increasing or decreasing. It should be super easy. The y-intercept is that a term, the starting value, the first number you see. So here the y-intercept is at 5, or I'll write it as an ordered pair, 0, 5. And because this growth rate of 4 is greater than 1, the function is increasing. For b, my y-intercept is the first number I see, 0.5, 1/2. Here the growth rate again, 1.25 is greater than 1, so you are increasing. In c, the y-intercept is 7, and 0.9 is less than 1, so this is exponential decay, and you're decreasing. Finally, in the last one, the y-intercept is 56. Now, 3 over 2, that fraction, it is a fraction, but that's a fraction that's less than 1. I'm sorry, no, it's not. That's a fraction that's greater than 1, so our function is increasing. Okay, that should be super easy. Now, you're going to need your calculator for this next part because we're going to graph an exponential function. So let's identify some things before we get started. We have y equals 8 times 2 to the x. Here the y-intercept is 8, that's your starting value. The growth rate is 2, and because 2 is greater than 1, this is going to be an exponential increase. Now you can use your calculator to fill out the table to plot the points. So when you go to your calculator, you're going to go to your y equals. Now just make sure that when you type the exponent in, you make it use the caret so that the x actually goes in the exponent. All right, make your table, and we're going to start our table at -5. So here that'll be 0.25. So use your calculator, find those values, and then we're going to copy those into the table. Okay, so we'll have 0.25, 0.5, okay, so hopefully you have those values. Now I want you to carefully copy those points onto your grid. Okay, so my grid's a little bigger, so I'm going to move it down here, but -5.25. So just estimate where 0.25 is down here. -4.5, halfway up there. -3.1. -2, 2. I think it's a -1, 4. Yeah. -1, 4, which is right here. 0, 8. I think from here now we can see 0, 8, 1, 16, and that's actually all that's going to fit on your grid. So I'm going to connect these. I'm going to use a brighter color to see here. I'm going to connect them. Now we know my graph's going to continue up. We just didn't have room, so I'm going to put an arrow here on either side. So let's answer a couple questions. We've talked about asymptotes before. Remember, asymptote is a line that the graph approaches but never reaches. Notice that this arrow on the bottom, if I look at my table on my calculator, I notice those y values, 0.25, 0.125, 0.0625, they get really, really small. But they're not actually getting to 0. You can kind of see that trend here when I look at the graph. It's getting really close to the y-axis, but not quite getting there. So there is my asymptote. That's at the y-axis, or I'm sorry, the x-axis, which is y equals 0. Now the domain of this function is actually all real numbers. I have an arrow going to the left towards negative infinity, and my arrow on the right is also going towards infinity. My range, because I have an asymptote, the range is not negative infinity. I stop at the y-axis here. So my range goes from 0, but non-inclusive. Remember, we never actually reach 0 up to infinity. And I would characterize this, not just exponential increase, but we're going to call that exponential growth. And I think I ran out of room over here, but there is the word growth or decay. We're going to start with growth. All right, one more graph. All right, let's try this new function. 10 times 0.5 to the x. So we go back to our calculator, and we're going to change our function here. 10 times 0.5 to the x. Now our table is starting at negative 2 here. So at negative 2, I'll just scroll through, up to 4. So those should all be on there. So take a minute and copy those points onto your grid. So we have negative 240. All right. Now before we graph, it asks you, what point will g of 0 represent? Well, g of 0, that 0, 10, when I write anything as 0, 10, that's a y-intercept. And I should also know that because that is the starting value up here. So I have a starting value of 10 and a growth rate of 0.5. So let's take a minute and plot those points all on this grid below. So I start at negative 240, which is not going to fit on my grid. And then I have negative 120, that will fit, that's way up here. 0, 10, 1, 5, 2, 2.5, 3, 1.25, and 4.6. Okay, so as I connect those this time, I know my graph's going to keep getting smaller there, so I'm going to put an arrow on both sides. And I know it's going to keep getting smaller because if I look at my table, as I go 5, 6, 7, those numbers get really, really close to 0 again. So let's answer some questions here. So it says, I would characterize this function as, let me make this a little smaller so we can see. I would characterize this function as exponential decay this time. My graph is going down from left to right, and I know it's kind of curvy and goofy, but you know what it's supposed to look like. I can tell from the graph that it's decay because the trend is decreasing. Okay, we've talked about intervals of increase and decrease. Well, this trend, the whole graph, is decreasing, so it's exponential decay. I can tell from the equation, remember the equation here was 10 times 0.5 to x. I can tell from the equation that I'm decreasing because the growth rate, which is b, is less than 1. Right? The growth rate of b, which is 0.5, that's less than 1, so I know it's going to be decay. All right, last couple questions here. There's an asymptote. Well, the asymptote's in the same place at the x-axis, which is the line y equals 0. And just like the last graph, I also have a domain from all real numbers, negative infinity to infinity. I go with left forever and right forever. And my range, I never cross this y-axis. So my range starts at 0, non-inclusive. Remember, you don't actually get to 0, but goes up to infinity forever. All right, that's part 1 of the notes. That's the first video. If you need help on the second part, see video number 2.